CivilBay concrete Anchorage users. In this tutorial, I'm going to show you the two approaches in our program to design the circular pattern anchor bolt. In these YouTube videos, the description area, there is a link to download this PDF file. Okay, this PDF file basically is a working sheet for this video, so you can download from the description area of this YouTube tutorial. Okay. Okay, I already addressed in the past tutorials on how to look at this, how to design the circular anchor bolt pattern. Click on this link, you will get it. Okay. Okay, that's circular pattern anchor bolt and circular base plate design. All right. That's first tutorial. The other tutorial is vertical vessel skirt support. Okay, so that's vertical vessel, circular pattern anchor bolt, skirt support. Okay, so these two tutorials, you can click on these two links. You can find the specific design demo on how to do the circular anchor bolt pattern design, serving different purpose. So in this tutorial, I'm going to summarize the difference between these two approaches. Okay. So these are two links for the previous tutorials. You can check it before viewing this video. Okay. So we have two approaches for circular anchor bolt pattern design. One is for like pipe steel, circular steel column section like a pipe or CHS. Okay. We abbreviate this one as a CCS. The other approach is for vertical vessel skirt support. We abbreviate as VVS. There are two approaches here. So what's the difference between these two? They are both circular anchor bolt pattern. Okay, so CCS is more suitable for a steel column, circular section steel column. This one can be standalone circular column like a light post. It can also be a column, steel column in a steel frame. Okay, you get a foundation load and design an anchorage. The supporting concrete surface is most of the time a small area like concrete pedestal. All right. And VVS is more suitable for standalone single structure subject to moment, overturn moment, okay, such as vertical vessel or silo. The supporting concrete surface for this type of structure is normally a very large area. We call it concrete mat, okay, or octagon mat, concrete mat foundation. So that's a brief difference between these two applications. Okay, I have detailed. Okay, before I go to these 7 points difference in detail. Okay, there are 1, 2, 3, 4, 5, 6, 7. Before I'm going through, I go through these 7 point difference in details of this the difference between these two applications. I will show you how to assess this one. Okay, let's try the. So we call it as a CCS and VVS from now on. All right, that's a steel column and the vertical vessel. CCS, VVS. All right. So now let's try CCS. Basically, it's you get stuff from circular pattern anchor bolt plus circular column. Okay, so that pedestal is it's circular, and you can also go for rectangle concrete pedestal, but circular anchor bolt pattern. That's rectangle concrete pedestal with circular patterns, and the other one is circular concrete pedestal. Okay, let's call it CCS. How to get it? Okay, starting from anchor bolt pattern here, put down these two guys. The other one is VVS. Okay, so go to VVS. You have check these vertical vessel support input. You have to change this case to vertical vessel support to skirt support. Okay, you get VVS. Okay, then for a concrete pedestal, you have two options. It's octagon shape, concrete pedestal. You can also go for circular shape. All right. So let's show you. We go for octagon shape for now. All right. So that give you an idea how to, in our program, how to assess the CCS and VVS. So they are both circular anchor bolt pattern, all right? They are both circular anchor bolt pattern. So what's the difference? And which approach I should use when I designing my structure? Okay, which one is better suited for me? And why you create two approach in your programs. There's a reason behind this, all right? So let's go to details. First difference, anchor load with moment or without moment, okay? So VVS, the anchor load, is definitely, there is a moment involved, okay? It's more, this one is for vertical vessel. It can be also silo, steel silo, okay, for storage, industrial silo or whatever. Um, there is definitely moment load involved in this application, okay? There must be moment. The meanwhile, in CCS, we go to design load. We can take moment, okay, the input here. Okay, by the way, because it's circular anchor bolt, that one is for illustration purpose. As I say, low input, we don't implement the exact bolt pattern. All right, there's a circular bolt pattern here. Okay, but for low input, we don't update that. We just show you the low directions. That's it. Okay, circular bolt pattern. And the low, someone asked me why there's no two direction moment, because for circular patterns, normally you combine the lateral load in one direction, and circular pattern you can apply in any direction. So it's not necessary to be two-way bending. Okay. So normally what I do is I combine the lateral X and Y in one load and apply the moment, over the moment to the base. I get only one moment instead of two direction for circular anchorable pattern only. Okay, so uh, in these CCS, we have moment input for sure, but you can go without moment. Okay, actual low only. So we have an option of with and without moment. So um, that's the idea. In VVS, there must be moment, okay? But in CCS, we can go with and without moment. The second difference, okay, it's the supporting concrete pedestal. So look at this, okay? The CCS, you can have, I show you a minute ago, you can have circular pattern pedestal, octagon pedestal, okay? So that's VVS. Oh no, CCS. Okay, CCS is this guy. Okay, CCS. As I say, I show you before. That's circular concrete pedestal. You can go for rectangle concrete pedestal. Okay, that these are two options for CCS. But for VVS, you have concrete pedestal is octagon and circular. Okay, octagon, circular. So they are different. Okay, there's no rectangle here. But in CCS, there's no octagon. pedestal available. Okay, so the type of concrete pedestal is the difference for CCS and for VVS. Okay, the third difference, the item 3. Okay, for VVS we have an option. Okay, VVS, that's CCS. Okay, for VVS, let's go back to Autocon. We have friction factor. The idea is your steel base, the vessel or silo steel base, either flat circular steel base or ring base. In vessel design, they allow the static friction between the steel and concrete surface. The idea is that like one object put on a table, you use a finger to push it. Okay, that's called static friction force. Resistance, static friction resistance. So you increase the force in your fingers starting from 0 to a certain value. Below that value, the object on the table won't move because they have a static friction to resist your pushing force. But once your force increase above this value, a certain value, the object start to move. That's called a static resistance, static friction. So the for vessel, we have these PIP standard. There's a mu value. Okay, it's a static coefficient of frictions 0.55. So we normally handle that. We the lateral load applied to a vessel, for example. There's a shear force applied to the base. If this shear force is less than the static friction resistance, we assume that force won't go to anchor bolt, okay? Because the vessel base mobilize the static friction, and it balance with this lateral load. But if the lateral load, the factor to calculate this resistance is 0.55 multiply the weight of the vessel pushed against the concrete. But if this force, I don't know if I don't know, it's an empty weight or operating weight to calculate the PU. PU is I think it's a compression force. It's a combined force of empty weight and the overturn moment. Okay, combine a compression force multiply the friction factor to get the friction resistance and multiply strength factor to reduce 25% off. Okay, so once this resistance, friction resistance, is larger than your lateral load, the anchor bolt will not take any shear force. So in VVS, seems friction static resist shear. In VVS, seems it's particular for the vessel design. We have these options to provide the static friction coefficient and to check against the lateral load to calculate the static friction resistance, check against the lateral load. If its friction resistance is larger, the anchor bolt, the circular anchor bolt will take no shear. Okay, that's one of your option. If you don't like it, you don't want to consider that, you can set this mu value, friction coefficient to 0. Okay, then no matter what, the anchor bolt will take the lateral load. So that's the option here for VVS, but for CC, for CCS, okay, for CCS, we don't have this option, okay, we don't have this option. The lateral load have to design load, the lateral load okay, here has to go to the anchor bolt. Ledger load has to go to, we call it VY here, okay? VY had to go to this anchor bolt. So that's handling difference on handling the lateral load, the shear force, with static friction option in VVS and without this option in CCS. Okay. Item number 3. Item number 4. Design load input. Okay. Again, for vessel, the VVS. Let's bring the VVS here. Okay. The load input is under this one. Okay. We have a moment input. Shear input, the base shear, okay, base moment for wing seismic, and base shear, you take the maximum of these two case, either maximum of the shear of wing case or seismic case. And the actual load applied to the anchor group in VVS, in CVS, CCS, we ask you to input the actual load. It can be tensile, it can be complexions, okay? And that's in CCS, but in VVS, we don't have this actual load input. Instead, we ask you to input vessel empty weight and operating weight. It's unfactored value, okay? But in CCS, it's a factor value. And there's tensile options, but there's no tensile option in VVS. Obviously, there's no upward, okay, unless you tie the balloon to this vessel. There's no upward, only gravity load going downward, okay? So instead of actual load input in VVS, we have vessel weight, empty weight, operating weight input. It's unfactored value, but in CCS, the actual load input is factor value, and it allows the tensile. So that's the difference. And the low input options, okay, and also in VVS, we allow that overturn moment and base shear. The programmer calculate a single anchor tensile force and shear force for you. If you don't like that, you want to calculate yourself, we have the other option. You can input the single anchor bolt tensile, calculate by yourself. Okay, you are not happy with the program approach on calculation, you calculate yourself, and you input the single anchor, okay, maximum tensile and shear. That's the other options, but there's no such options in CCS, okay? So we have two options. We will choose input MU must be factor value after multiplying load factor. In VVS, actual input is vertical vessel. We already took that. In CCS, take care of multiplying factor. The same case, but not in the same case for actual load. Okay, you can check with this one. Low input difference, okay? And the number of anchor bolt, okay. So that's VVS. We have number of anchors, circular pattern, 12 number, okay, 12 number. You can input any number here, okay. No limitation, okay. Let's say 9 number, okay. 9 number, 6 number, okay. In the, okay, we go back to 12 number, all right. There's no limitation, can be any number. But let's VVS in CCS, we can anchor bolt patterns. Okay, go to dimension. Let's put down here number of anchors, circular pattern. We have only option of 5, 6, 8, 9, 10, 12. That's it. We don't allow other options. Okay, so in CCS, the number of anchor in a circular pattern is limited to 5, 6, 8, 9, 10, 12. That's it. Okay, 6. So that's the difference. In VVS, there's no limitation. Design basis assumption. Excuse me. Okay. The look at this CCS, okay? Uh, how we work out the anchor bolt tensile force? There's a balance, okay? Okay, let me explain this way. When we work out the anchor bolt tensile force, we consider the because the base plate is touching the ground or concrete surface, we consider the reaction of the concrete reaction of the concrete surface in the equilibrium. Okay, so I've explained to you. That's accurate approach. All right. So I bring out this one, bring this one. So look at this. Oh no, there's no tensile force. Okay, so we increase the moment. Let's increase the moment. Okay. It seems the moment is too small. Okay. No tensile mobilize. Design load. Okay. Let's see 15 instead of tensile. We get 1, 2, 5. Update. It's too huge, and we go for 25. Update. Okay, now 35. Okay, now go to and print it. Okay, print it. Okay. So look at this diagram. Okay, when go to equilibrium. Okay, you work. You calculate the tensile load on the under the moment. All right. I'm talking about the design with moment case, with the moment load case. Under the moment, we have mobilized tensile in the anchor. Meanwhile, there is also a reaction of concrete pressures going upwards here because you push against the concrete. You push against, you have a moment, okay? You have a moment. Side view. All right. You have a moment. 35. You push against the ground or concrete surface, there's a reaction here. So, these reactions is counted in the equilibrium of this base plate. When you have external load, you have tensile force in the anchor. You also have a reaction of the concrete reactions. They is counted all together. To this base plate must be balanced. Okay, that's how you get the length of the concrete stress block. In CCS, we consider that. Okay, we consider that, but in VVS, okay, it's not the case because we simplify. That's very complicated approach. In VVS, look at this design force calculation. We have this assumption in VVS. The moment resists only by anchor group, and it doesn't take into account the contribution of concrete compression force against the base plate in the moment equilibrium. Okay. Let's design assumptions, a simplified approach. If we ignore that, which is not accurate, but it's conservative because the anchor tensile force will be larger. It's not that accurate, but it's conservative. So your design is still safe, but you waste some material because let's say 20-30% larger of the anchor load tensile force, which is not accurate, but it's larger. But you design more for that. Okay, that's a convention in vertical vessel design. So that's the way people do it. Simplified approach. Okay. That's VVS, but let's VVS in CCS, we go for accurate approach. Okay, so your design might pass in CCS but not pass in VVS. It's because CCS is more accurate. It generates accurate anchor load. So VVS is conservative. It generate larger anchor load. So that's the reason. So that's the design basis assumption. So normally in one shot, in short, CCS is accurate approach, and VVS is simplified approach. We have discussion here, design basis assumption. You go to detail in this one, okay? So that's a design assumption difference between these two, and you can check this out. And the last item is a base plate design, right? So again, go to the item six, okay? Design based assumption. We address the difference with VVS. There's no concrete. Okay, I mean, where is it? It doesn't take into account. Okay, it doesn't take into account in VVS the concrete contribute concrete compression force. Okay, but in CCS we take this into account. But there's one more note here. Okay, that's for these grouting options. Okay, we have these options. We have this option. That's for we have this option. We have standoff with grout and standoff without grout. In these two cases, base plate push against the concrete surface. But for the standoff option, like these two guys, seems the base plate is detached from concrete surface, so there's no difference. For these two cases, there's no difference in terms of design assumption between CCS and VVS. All right, so if you go to these two guys, there's no difference from there. Okay, but only the first two you have difference. Design based assumption, base plate design. Okay, so when you go for these two options, when you go for side view, okay, the side view, you see this standoff option. That's grouting. If you go for these options, anytime you go for this option, detach, okay, 2-inch. Anytime you go for these options, there's no grout. The base plate detached from concrete surface. There's no base plate design. Okay, so only when you go for grouting or the base plate touching the concrete surface, we provide the base plate design in these two options. Okay, so in these two options we have base plate design. In these two options we have no base plate design. Okay, and because the base plate is not touching concrete, it would be more accurate if you model the base plate as a final element and do the final element stress analysis in a program like StatPro, Sub 2000 or RISA. Okay, but when you touch concrete, we provide the base plate design based on AISC design guide 1, I believe. So in CCS, we have base plate design when your base plate touching concrete, but in CCS we don't have base plate design in any case. The reason is that for vertical vessel, normally the ring plate design or vessel base plate design is by vendor. It's not by structure engineer, so it's not our interest to design the base. It's quite different. A silo, vertical vessel, or whatever. The way they implement the base ring plate or whole base plate or fiberglass, whatever, or anchor chair is quite different. Okay, there's no way we can do the base plate design in this vertical vessel support case. There's no base plate for VVS, but in CCS, there's base plate option when you pick the option of base plate touching the concrete surface. We have base plate design option. Okay, so that's the main difference. Okay, for you to decide which approach you should use for your circular pattern anchor bolt design. Okay, so you check through these difference, and pretty much we also show you how to use these two approach. So one more last note, you decide yourself. After this, we close this one. One more last thing. Okay, for well, that's CCS. For VES, okay, when you finish it, if you are in vertical vessel mode, you want to go back to normal anchor bolt design, input, whatever, you have to change this to not vertical vessel case. Okay, in that case, you can get all the input here. But if you stay with skirt support or leg support, I have another tutorial on that. You go through the YouTube tutorial, you will know that. Okay, if you stay with skirt support, you won't get the you stay with skirt support, you won't get anything. Okay, you won't get the full one. Okay, so only things they assume you are still on vertical vessel design. Only way you can run out of this mode, vertical vessel mode, is go to vertical vessel support and change these to not vertical support, vertical vessel case. In that way, you can get all this input back. Okay, so that's it. See you next time. Have fun.